All right. So our last lesson has to do with the derivatives of composite functions. So combining derivative rules, okay? We can combine several derivative rules in order to differentiate a complex product and quotients. Okay, so this is the rules that we've learned. You guys are gonna have to apply them all as we speak. So, for example 1, we want to write a simplified expression for the derivative of h of x if h of x is equal to x squared times 4x squared minus 5 times 6 plus 3x all to the power of 5. Then we want to find h at 1. So, we can label each one as p of x, q of x, and then we can just label this r of x. All right? So what we can do here is we have to use a combination of the product law and also along with the power of a product law for derivatives. All right? So we need to find h prime of x. So what that look like is it would be the derivative of p of x multiplied by q of x times r of x plus the derivative of q of x times p of x times r of x plus the derivative of r of x times q of x times p of x. As you guys can see, this is already going to get annoying. So now the first one we have is the derivative of p of x. So what is my derivative of x squared? Two x. So I can take 2x multiplied by 4x squared minus 5 to the power of 3 times 6 plus 3x all to the power of 5. So before we get into it, let's do each derivative separately. So p of x we said was 2x. Now the derivative of q of x, what rule for derivatives do we have to do for the derivative of q of x? Already, power of a function. Okay. So a power of a function means I'm going to take my exponent, bring it as my coefficient in front of that function, and then subtract my exponent. I'm going to get 3 times 4x squared minus 5 to the power of 2. And then I have to multiply it by the derivative inside of the function. So who can tell me the derivative of 4x squared minus 5? 8x. So now to make my life easier, I'm going to multiply 3 and 8x, which gives me 24x times 4x squared minus 5 times all to the power of 2. Okay, so that would give me my derivative of q of x. And now derivative of r of x, what would that give me? Let's see if someone can help me out with this one. So 6 plus 3x all to the power of 5. What would the derivative of that look like? All right, perfect. So we have 5 times 6 plus 3x all to the power of 4 multiplied by 3. Again, we can multiply the coefficients outside of the bracket, which gives me 15 times 6 plus 3x all to the power of 4. So in this question, we are using product law plus the power of a function. All right. So now with that said, I can live my life easy and I can just plug in everything as we speak. So now this makes this question much more bearable now that we know what to do. So the next one is now I have to add the derivative of q of x plus multiplied by all the other functions. So my q of x is 24x times 4x squared minus 5 squared multiplied by x squared times 6 plus 3x to the 5. And as you can see, it's going to get annoying because now I have to start my whole line at the bottom. So I get plus, and then my derivative of r of x, which is 15 times 6 plus 3x, all to the power of 4, multiplied by x squared, multiplied by 4x to the power of 2 minus 5, all to the power of 3. All right. So now what I have to do is I can simplify more. So I can multiply 24x by x squared and 15 by x squared. So what I'm left with is 2x times 4x squared minus 5 to the power of 3 times 6 plus 3x to the power of 5 plus 24x times x squared is 24x cubed times 4x squared minus 5x squared times 6 plus 3x all to the power of 5. And then plus 15x squared times 6 plus 3x to the power of 4 times 4x squared minus 5 to the power of 3. How many of you guys are freaking out already? Yep, headache. This is going to be a very long solution. Too many numbers, exactly. And it doesn't help that when we find the value of the derivative of h at 1, it doesn't help that it's also a gigantic number. Yep, we have returned to full page problems. Exactly. That is what we have come to. In all fairness, there are only 2 questions that are like half a page to a full page, but that's besides the point. So now let's look at this whole expression. Is there a common factor that I'll be able to factor out? Okay. Your last one, Mohammed, should be 6 plus 3x to the power of 4. Because we have 6 plus 3x to the power of 5, to the power of 5, and to the power of 4. That's fine. So I can factor out a x times 4x squared minus 5 squared times 6 plus 3x to the power of 4. Ooh, now we're going to make it smaller. So once I do that, on the inside, I'm left with 2 times 4x squared minus 5 times 6 plus 3x plus 24x squared times x plus 3x plus 15x times 4x squared minus 5. And now, guys, guess what you have to do in the inside of the bracket? Does anyone want to take a stab at what you have to do on the inside of the bracket? Something very tedious. We're going to expand and simplify, okay? So that means I'm going to FOIL everything and try to come up with a simplified expression on the inside. Okay? I'm not going to go through the whole thing because I trust your guys' expanding and simplifying. So I'm going to give you the simplified form already. So I got x times 4x squared minus 5 all squared times x 6 plus 3x to the all to the power of 4. And once you simplify what's on the inside, you get 156 x cubed plus 192 x squared minus 105x minus 60. Okay, so we brought it down to a much simpler expression to work with. So can I factor out any number from my bracket over here? Is there a common factor I can factor out? A 3. So I'm going to factor out a 3. So I am left with 3x, because I factored out the 3, times 4x squared minus 5, all squared, times 6 plus 3x to the 4, multiplied by 52x cubed plus 64x squared minus 35x minus 20. I promise you guys we're almost done. Okay? For those who are copying it down, is your hand hurting already? All right. Yeah, trust me, when I was writing these notes down and was doing solutions, my hands started to hurt. So, can we factor out anything else? Is there anything else we can factor? We can factor out this thing over here. We can factor out a 3, okay? So we're left with, so if I factor out a 3, I'm left with 3 times 2x times 2 plus x, and all of this is to the 4, okay? So when I factor that out, I'm left with that, which means that this then becomes, so I get 3x times 4x squared minus 5 all squared times 3 to the 4 times 2 plus x to the power of 4 multiplied by 52x3 plus 64x squared minus 35x minus 20. Now I can multiply my 3 to the 4 with my variable on the outside, which means I get 243x times 4x squared minus 5 times 2 plus x to the power of 4, all multiplied by 52x3 plus 64x squared minus 35x minus 20. And finally, now we can actually evaluate for h, derivative of h at 1. So you guys can help me out. If I sub in 1 for all of my x values in the derivative, what is the derivative of h when x is equal to 1? Let's see if you guys don't mess up this calculation on your calculator. So sub in 1 for x in the derivative. And then tell me type in the chat what number you get. It can't be a negative because all the exponents are even. Positive 1,200,663. If you guys go on Desmos and freaking write down this whole function, I wonder what kind of graph it gives you. So what does that value mean? The derivative of h at 1 is 1,200,663. What does that represent? Remember, what does the derivative help us find? Remember, guys, what this, the instantaneous rate of change, exactly. So that means the instantaneous rate of change at x is equal to 1 is 1,200,663. So something is moving very, 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 very fast at that point on the graph. What could it be? Who the hell knows? Okay. But the way I would approach these questions is the way I did it over here, is identify what rules you have. So for example, because you're multiplying different functions together, you automatically have to do the product rule. And because each of those functions, or two of those functions, have expressions on the inside all to a specific power, you have to do the power of a function rule, okay? I'm going to give you guys the opportunity to try to do A by yourself, or example 2A by yourself. I will come up with your hints, and then you guys can go from there. So, example 2A is we want to differentiate and express in simplified form. So we have y is equal to 2x squared minus 1 all to the power of 4 times x to the 3 plus 5 all to the power of 2. So again, we can label this guy as p of x, and I can label this guy as q of x. So what are some laws or rules that we are going to be using to find this derivative? So this is how you're going to start off these questions, because this is probably going to be the way that you're most organized in order to not mess up. So Mohammed, we're going to use the product rule, thank you. And Is that Ricardo? Yeah, we're going to use power of a function. So now on the side, what you guys would do is find your derivative of p of x. So what would my derivative of p of x be for 2x squared minus 1 all to the power of 4? So remember, power of a function, you take the exponent, bring it to the coefficient, and subtract the exponent by 1, multiplied by the derivative of what's on the inside. Trust me, this makes your lives easier once you have everything organized properly. So whenever someone has found the derivative of p of x, let me know. Okay, let's do it together. Let's check if Mohammed's answer is right. So I got 4 times 2x squared minus 1, all to the power of 3, multiplied by the derivative of the inside, which is 4x. So now I can multiply my 4 and 4x together, which gives me 16x times 2x squared minus 1, all to the power of 3. So that would be my derivative of p of x. Okay, does everybody agree with that? And now we're going to go to q of x. I think Mohammed also solved that. So again, same situation. So we get 2 times x to the 3 plus 5 to the power of 1, multiplied by the derivative of the inside, which is of x3, which is 3x squared. Now I can multiply my 3x squared by 2, which gives me 6x squared times x to the 3 plus 5. Did everyone get both of these answers? Okay, perfect. Now what you guys can do is use your product rule, which states that h of x, or derivative of h of x, is equal to the derivative of p of x times q of x plus the derivative of q of x times p of x. Okay? So what we have here is we have 16x multiplied by 2x squared minus 1 to the power of 3, multiplied by q of x, which is x to the 3 plus 5 all squared, plus my derivative of q of x, which is 6x squared times x to the 3 plus 5, multiplied by 2x squared minus 1, all to the power of 4. So out of this whole expression over here, is there a common factor that I can factor out to make it simpler? And if so, what is the factor I can take out to make this as simple as possible? So I can factor out 2x squared minus 1 to the power of 3, and x to the 3 times 5. Thank you, Priyanshu. So that's what I'm going to factor out. 2x times 2x squared minus 1 to the power of 3 times x to the 3 plus 5. And if I factor that out, I get remaining 8 times x to the 3 plus 5 plus 3x times 2x squared minus 1. And now what's left to do is to expand and simplify my bracket. So multiply 8 by my binomial here and 3x by my binomial on the other side of the plus sign. So what I get when everything is simplified is 2x times 2x squared minus 1 to the power of 3 times x to the 3 plus 5, all multiplied by 14x cubed minus 3x plus 40. And because I cannot simplify anymore, my derivative is going to be 2x times 2x plus minus 1, all to the power of 3, times x to the 3 plus 5, times 14x cubed minus 3x plus 40. So was that terrible, or is it easier to kind of figure out what to do now? The reason why it's better than the previous one is because we organized it properly, so we knew what to do right from the get-go. Okay, so everyone's happier now. Perfect. All right. So now we have our next one. So you want to differentiate y is equal to x squared minus 2 all to the power of 4 divided by the root of x to the 3 plus 3, and we need to differentiate that. Okay, so let's start by making our lives easier. So we can have x squared minus 2 all to the power of 4 divided by x to the 3 plus 3 all to the power of 1/2. So now we need to figure out our rules. So what rules are we going to be using to find out the derivative of this function? We use quotient rule. And what else? There's one more rule that we need to use. Power of a function. Okay. So before we do anything, let's go back to what the quotient rule states. So in order to find the derivative of this, so h of x, the quotient rule suggests that we take the derivative of f of x multiplied by g of x minus the derivative of g of x times f of x divided by my function g of x squared. So we can take this guy at the top. This is our f of x, and this is our g of x. So now let's find the derivatives of each one separately. So let's find the derivative of f of x. What would that give us? So again, we have to use the power of a function rule to figure out the derivative of f of x. The more organized you get your questions set up, the easier it becomes to just simplify pretty easily. Okay, thank you, Mohammed. So we bring the 4 in front, and we get x squared minus 2 to the power of 3, multiplied by the derivative of x squared minus 2, which is 2x. And I can multiply my 2x by 4, and I get 8x times x squared minus 2, all to the power of 3. So that is what my derivative of f of x would be. And now let's look at the derivative of g of x. Okay, so what would my derivative of g of x be? The reason why I suggest you guys do it this way is to avoid using the power of a function and using it in an unsimplified way. We can just simplify it right away by doing work on the side. So what would my derivative for g of x be? Okay, thank you, Mohammed. So I am going to be getting 1 over 2 x to the 3 plus 3 to the power of negative 1/2, multiplied by the derivative of the inside, which is 3x squared. So I can multiply 1/2 and 3 over 2x squared. And I'm left with 3 over 2x squared multiplied by x to the 3 plus 3 to the power of negative 1 over 2. So now my life becomes 100 times easier now that I figured out the derivatives for f of x and g of x. So now I can plug in my values. So I get the derivative of f of x, which is 8x times x squared minus 2, all to the power of 3, multiplied by g of x, which is just x3 plus 3 to the power of 1/2. Subtract the derivative of g of x times the derivative of f of x, which we get negative 3 over 2 x squared times x3 plus 3 all to the power of negative 1 over 2, multiplied by x squared minus 2 all over 4, which is divided by g of x squared, which is x3 plus 3 all to the power of 1/2, and that's all squared. So now what I have to do is I need to simplify. Okay, so I can simplify my denominator. So I have 8x times x squared minus 2 to the power of 3 times x to the 3 plus 3 to the 1/2 minus 3 over 2x squared times x to the 3 plus 3 to the power of negative 1/2 times x squared minus 2 all to the power of 4 divided by x cubed plus 3, because power to a power, you multiply the exponents, we get 1/2 times 2, which cancels out to just give me 1. So I have a fraction that has a denominator of 2 in my numerator. What can I multiply by to get rid of that fraction because I really don't want it there? So what do I multiply my numerator and denominator by to get rid of my fraction? we'll just multiply by 2 for now. Okay, and then we can simplify later. So I'm going to multiply this guy by 2 and multiply all of this by 2. So I'm left with 16x times x squared minus 2 to the power of 3 times x to the 3 plus 3 to the power of 1/2 minus 3x squared times x to the 3 plus 3 to the negative 1/2 times x squared minus 2 to the power of 4, all divided by 2 times x3 plus 3, and that would be it. However, now we have to simplify. So, is there anything from the numerator, a factor, that I can simplify my numerator to be? So the factor I can take out from my numerator to simplify everything will be x times x squared minus 2 to the power of 3 times x to the power of 3 plus 3 to the power of negative 1/2. And what's left on the inside would be 16 times x cubed plus 3 minus 3x times x squared minus 2 all over 2 times x cubed plus 3. If you guys want to check if the factor works out, you can just expand again and see that it is a common factor between those two expressions. So now I can simplify even more. So this gets me 2x times x squared minus 2. And then I'm going to simplify the inside of the bracket, which gives me 16x cubed plus 48 minus 3x cubed plus 6x. Because I don't want exponents that are negative on the top, I can just bring my x3 plus 3 to the negative 1/2 to my denominator, which gives me 2 times x to the 3 plus 3 times x3 plus 3 to the power of 1 over 2. And I can simplify even more because I can simplify one of the brackets in the numerator, and I can use exponent laws for my bottom because x3 plus 3 is the same base. So now I can add my exponents 1 plus 1 over 2. And my final answer will give me x times x squared minus 2 to the power of 3 times 13x cubed plus 6x plus 48 all over 2 times x to the 3 plus 3 to the power of 3 over 2. So how are your brains doing right now? It's not your brain, it's your hand. Is everyone's hand okay? Who here had to take like multiple breaks while writing the solutions? All right, we have one more question, guys, and we are done for the day. The next one's not going to be that difficult. It's actually going to be pretty simple to understand. So hopefully everyone's doing pretty well. Give you guys a minute to copy that down, and then I'll move on to the next exam. On the assignments, I only gave you 2 of them that are like decently long, but not like full page long. So just be prepared for those 2. Okay, so let's move on to the last one and call it a day. So the next one we have is we want to find the derivative of y is equal to x cubed minus 2 divided by x cubed plus 2, all to the power of 5. So just by looking at this function, what type of rules do we have? Should be pretty noticeable right off the bat. Okay, we do have power of function and quotient, but we have one more. It's the one we did last lesson. Starts with a C, chain rule. So we have my chain rule, which means that I have f of g of x, okay? That's what my chain rule means. So if you guys remember, chain rule is found by h of x is equal to the derivative of f of g of x multiplied by the derivative of g of x. All right, so we have our function. Can anyone identify what my function f of x will be? X to the 5. X to the power of 5. So what will my derivative f of x be? What would be the derivative of f of x? Come on, guys, this one's pretty easy. Derivative of x to the 5, what is it? 5x to the 4. So now we can automatically start doing our chain rule. So I have f prime of g of x. So I have 5, and then a function all to the power of 4. Because g of x is on the inside, this whole expression is going to go in the bracket. So I have x to the 3 minus 2 over x to the 3 plus 2 multiplied by the derivative of g of x, which is just quotient law. Okay? So I need the derivative of the top times the derivative times the bottom. So what is the derivative of x3 minus 2? So I get 3x squared multiplied by x3 plus 2 minus 3x squared times x3 minus 2 all over x to the power of 3 plus 2 all squared. So now, let's make this as easy as possible. So remember, guys, this exponent goes to both the expression x to the 3 minus 2 and x to the 3 plus 2. So I can simplify this as 5 multiplied by x to the 3 minus 2 to the power of 4 divided by x to the 3 plus 2 to the power of 4 multiplied by simplifying the inside, which gives me 3x5 plus 6x squared minus 3x5 plus 6x squared all over x3 plus x2 all to the power of 2. So now, as you can see, 3x5 and minus 3x5 cancel out. So I'm left with 5 times x to the 3 minus 2 to the power of 4 divided by x to the 3 plus 4 to the power of 4 multiplied by 6x squared plus 6x squared, which is 12x squared, divided by x to the 3 plus 2 all squared. My apologies, this should be plus 2. I don't know why I changed it. All right. So now I want you guys to give me my simplified answer. So what would my final answer be if I were to simplify everything? So our denominators can be done using exponent laws because we have the same base with x to the 3 plus x to the 2. So if you guys can write me the final answer, that would be awesome. (60x squared times x3 minus 2 to the 4 over, yep, thank you, Priyanshu. So again, we're going to do 12x squared times 5, which gives me 60x squared times, you leave the bracket alone. And because we have exponent laws at the bottom, same basis with exponents being multiplied, my denominator simplifies to x3 plus 2 all to the power of 6.